Splash into the supercold. Imagine a swimming pool on a hot summer day. Now picture a pool filled with something mysterious and unbelievably cold. This isn't ordinary water, it's liquid helium, one of the coldest substances on Earth. If you fell in, would you freeze instantly, float, or sink? The real science is even stranger than fiction. So, get your science goggles on. We're about to dive into the wild world of liquid helium. First, what exactly is helium? Helium is one of the simplest and most fascinating elements in the universe. It sits right at the top of the periodic table, with the atomic number 2, making it the second lightest element after hydrogen. Helium is a noble gas, which means it doesn't like to react with other elements, and it's colorless, odorless, and tasteless. It's also incredibly abundant in the universe, especially in stars, where it's formed through nuclear fusion. You probably know helium best from party balloons. It's the invisible super-light gas that makes balloons float effortlessly into the sky. And if you've ever inhaled a little helium from a balloon, you know it can make your voice sound hilariously squeaky, like a cartoon character. But helium isn't just for parties. It's actually a crucial element in science and technology. Now here's where things get really interesting. To turn helium gas into a liquid, you have to make it unimaginably cold. Far colder than anything you'll find in your kitchen freezer, and even colder than the harshest winter day in Antarctica. We're talking about temperatures that are almost impossible to experience anywhere on Earth. Liquid helium only forms at a temperature just 4 degrees above absolute zero. Absolute zero is the lowest temperature possible, where all molecular motion stops. That's minus 273.15 degrees Celsius, so liquid helium forms at about minus 269 degrees Celsius. It's a temperature so cold it's hard to even imagine. That's minus 269 degrees Celsius, almost unimaginably cold. At this temperature most substances would be frozen solid, but helium becomes a clear, flowing liquid. It's so cold that even the air around it can freeze, creating dramatic clouds of vapor and frost. When you look at liquid helium, it might remind you of water because it's clear and flows easily. But don't be fooled, this is one of the most extreme and unusual substances scientists have ever worked with. It doesn't behave like ordinary liquids. For example, at even lower temperatures it can become a superfluid, able to climb up and over the sides of containers, defying gravity in ways that seem almost magical. You won't find liquid helium in nature, not even in the coldest places on Earth. It has to be made in special laboratories using powerful machines called cryocoolers, or liquefiers, which squeeze and chill the helium gas until it turns into a liquid. These labs are filled with high-tech equipment and safety gear because working with such cold substances is both challenging and dangerous. So, liquid helium is the ultra-chilled, liquid form of the same element that makes balloons soar and voices squeak. But in the world of science, it's a superstar, used for cooling powerful magnets in MRI machines, enabling quantum experiments and unlocking the secrets of the universe. Science is truly amazing. Liquid helium isn't just cold, it's weird. When it gets even colder, it becomes a superfluid, a liquid with zero viscosity. That means it can flow without friction, creeping up walls and through tiny cracks like a ghost. Superfluid helium can even make objects hover or skitter on its surface thanks to rapid boiling underneath. It's not like any liquid you've seen, this is quantum physics in action. Superfluid helium can spin forever, never slowing down. It's a glimpse into the strange world where the usual rules of liquids don't apply. Welcome to the quantum playground. Imagine for a moment standing at the edge of a massive gleaming tank filled with liquid helium, the coldest substance on Earth. What would actually happen if you fell in? It's a question that sounds like pure science fiction, but the reality is even more chilling than you might expect. First, let's be absolutely clear, this is a scenario for science only. Never, ever try it. Cryogenic liquids are incredibly dangerous, and even being near them requires special training and protective gear. These areas are strictly off-limits for a reason. The moment your skin made contact with the liquid helium, the results would be catastrophic. At a temperature just a few degrees above absolute zero, liquid helium is unimaginably cold. Your skin and the tissues beneath would freeze solid almost instantly, far faster than with dry ice, or even liquid nitrogen. The water in your cells would crystallize in a split second, turning soft tissue into something as hard and brittle as glass. This isn't just frostbite, it's a total body freeze. Your entire body would become rigid, encased in a layer of frost, and so brittle that even a small impact could cause frozen limbs to snap or shatter. The cold would penetrate deep, freezing muscles, nerves, and even bone in a matter of seconds. The freezing wouldn't stop at the surface. Within moments, the cold would reach your vital organs, your heart, lungs, and brain, stopping blood flow and halting all biological processes. Your organs would freeze solid, and the blood in your veins would turn to ice, making any chance of survival impossible. But the danger doesn't end there. As your much warmer body enters the liquid helium, it would cause the helium to boil violently, releasing a thick swirling cloud of helium gas. This vapor would quickly fill the air around you, creating a dense, cold fog that's both eerie and deadly. Helium itself isn't poisonous, but it's a silent suffocator. As the gas cloud expands, it pushes out all the oxygen in the area. Inhaling helium instead of air means your body gets no oxygen at all, and you'd lose consciousness in just a few seconds. Even if you somehow avoided freezing, you'd have no air to breathe. So, it's a double threat: instant deep freezing that destroys your body from the inside out, and a suffocating cloud of gas that makes breathing impossible. There's no way to escape either danger once you're in. The human body is made up of about 60% water, and at these temperatures, every drop would freeze solid. The cold would move so quickly that your body's natural defenses wouldn't even have time to react. In a world where water is life, liquid helium is instant death. The entire process would be over in the blink of an eye. No emergency team could reach you in time, and no amount of medical intervention could reverse the damage. It's a terrifyingly fast and final fate. That's why liquid helium tanks are marked with so many warnings. They're a no-swim zone for a reason. One misstep and the consequences are instant and absolute. How cold is liquid helium, really? Let's compare. Antarctica's coldest temperature, -89 degrees Celsius. Dry ice, -78.5 degrees Celsius. Liquid nitrogen, -196 degrees Celsius. All of these are freezing, but liquid helium is in a league of its own at -269 degrees Celsius. That's just a few degrees above absolute zero, the coldest temperature possible. Even the average temperature of outer space is only slightly colder. Liquid helium is the ultimate champion of chill. It's so cold, it's almost at the very bottom of the temperature scale. Nothing on Earth is naturally colder. That's why it's so special, and so dangerous. Why is liquid helium so dangerous? First, it causes instant deep cryogenic burns, freezing your body's water in a flash. Second, it evaporates into a huge volume of helium gas, quickly displacing all the oxygen around you. Without oxygen, you'd pass out and suffocate in seconds. The rapid expansion of helium gas can also cause containers to explode, if not properly vented. Materials exposed to liquid helium become brittle and can shatter, even metals. That's why scientists use special insulated containers and protective gear. Even a small spill can create a dangerous cloud of cold gas. Liquid helium demands respect and extreme caution. Safety first, always. If liquid helium is so risky, why do scientists and engineers go to such lengths to use it? The answer lies in its truly extraordinary properties. Liquid helium is the coldest substance on Earth, reaching temperatures just a few degrees above absolute zero. This makes it an irreplaceable tool for some of the most advanced science and technology on the planet. Its extreme cold isn't just impressive, it's absolutely essential. Many materials behave in completely new ways at these ultra-low temperatures, and liquid helium is the only substance that can get us there. It's the secret ingredient behind some of the world's most powerful and precise machines. For example, in hospitals, liquid helium cools the superconducting magnets inside MRI machines. These magnets need to be kept incredibly cold to work, and only liquid helium can do the job. Thanks to this, doctors can see detailed images inside the human body, helping them diagnose illnesses and injuries without surgery or invasive procedures. In the world of physics, particle accelerators like the Large Hadron Collider depend on liquid helium to keep their massive magnets super cold. These magnets steer and accelerate particles to nearly the speed of light, allowing scientists to explore the fundamental building blocks of the universe. Liquid helium is also crucial for studying the weird and wonderful world of quantum mechanics. At these low temperatures, helium becomes a superfluid, a state of matter with zero viscosity that can flow without friction. This lets researchers observe quantum effects that are impossible to see at higher temperatures. By enabling these experiments, liquid helium helps scientists unlock the secrets of the universe at the tiniest scales, from the behavior of atoms to the mysteries of superconductivity and beyond. In research labs everywhere, liquid helium is a true hero. It powers discoveries that change our understanding of nature and drives the development of life-saving technologies. Without it, many of the breakthroughs we take for granted simply wouldn't exist. Imagine a world without MRI scans, advanced particle physics, or the ability to study quantum phenomena. That's a world without liquid helium. Its unique abilities make it a cornerstone of modern science and medicine. So while it may be tricky to handle, liquid helium is a true superstar of science, quietly enabling discoveries, saving lives, and pushing the boundaries of what's possible. Liquid helium's uses go far beyond hospitals and labs. It cools sensitive instruments on space telescopes, letting us see faint signals from distant galaxies. In rocketry, helium gas, often starting as liquid, pressurizes fuel tanks, helping launch rockets into space. It's used in advanced materials research, revealing new properties at ultra-low temperatures. Liquid helium even helps create ultra-stable environments for experiments like gravitational wave detection. From saving lives to exploring the universe, liquid helium is a quiet force behind progress. Its extreme cold opens doors to new discoveries. Science rules! Our journey into the world of liquid helium shows just how strange and powerful nature can be. Studying it unlocks secrets about matter, energy, and the quantum world. The dangers of liquid helium teach us about safety, respect, and innovation. Each challenge leads to better technology and new discoveries. Liquid helium is more than just a cold liquid. It's a key to understanding the universe. It powers life-saving tech, fuels exploration, and inspires curiosity. The universe is full of wonders, and liquid helium is one of the coolest.